Okay, in this video we are going to solve equal complex numbers. But before that, we need to first be reminded about complex numbers are in this form. So we have Z, which is one of the complex number. Then we have W, which is also one of the complex number. We can have C plus DI. So we have two complex numbers, Z and W. If Z is equal to W, which means if these two complex numbers are equal, therefore the real parts are going to be equal to each other. That means A will be equal to C and B is going to be equal to D, which means this A will be equal to this C because they are real part of it. Then this B is going to be equal to this D because they are imaginary part of them. So it is basically that if there are two complex numbers that are equal to each other, then therefore the real parts are equal to each other and the imaginary parts are equal to each other. So in a case whereby we are having this question, it says determine, let me just use the black one. Yeah, determine, I'm sorry for this one. Determine the values of m and n if 1 plus 3i is equal to, we have 2 plus I, then we have m plus ni. So in this one, this is the complex number. We know it is in this form of Z or W, and this one, because there is an I in it, it is a complex number. But the problem now is that this one is simplified and this one is not simplified. So this one is simplified because this is the real part of it, real part of this complex number, and this one is the imaginary part of this complex number. Then in this case, you may not necessarily identify the real and the imaginary, so we need to work this out a little bit so that it is going to be in this format. So let's take the right hand side. The right hand side is given by, we have 2 plus I, then m plus ni. So if you have this one, let's just expand it a bit. So we have 2m, then plus 2ni. When you take this one, then you plus mi. When you take the inners, then you have plus ni squared when you take the outers. Now, let's simplify it a bit. This one is going to be a real part of it because we remember in our last videos that I squared is equal to -1. So we are going to be having 2m then minus n when we take this one close to another real part of the solution. Then these ones, you can see that there is a common factor I. So if you are taking out the common factor I, you will be left with this information. So we have this. So we can see that the right hand side, the one that we were solving, this is the real part and this one is the imaginary part. Okay, so we can now associate the real parts are going to be equal to each other and the imaginary parts are equal to each other. So allow me to say we have yonke lento, which is equal to 1 plus 3i. So you can see that this is the complex number and it is equal to another complex numbers. What did we do when the complex numbers are equal? The real parts are equal to each other and the imaginary parts are going to be equal to each other. So in this case, this is going to be equal to 1 because these are real. Because how do you notice that they are real? Because they are not multiplied by I. And this one and that 3, they are imaginary parts, so we are going to equate them up correspondingly. Now let's have 2m minus n, which is equal to the real part on the other side, that it is equal to 1. Then you can just call this an equation 1. Then the second one, we are having the imaginary parts. They are going to be equal to each other. So we have 2n plus m is equal to another imaginary part on the other side. So we are going to solve these two equations simultaneously. Now we can just say solve m here. M is going to be equal to 3 minus 2n. Solving it from the second equation, then we do the substitution. Then if m is equal to that, so in the first equation we're going to have 2 times m, where m is equal to this, then minus n, then is equal to 1. Then we have 6 minus 4n minus n is equal to 1. Then of course we have minus 5 n, which is equal to, on the other side, is equal to minus 5, because when you take this one to the other side it becomes that. Then you have n being equal to just positive 1. Then if that is the case, you substitute it here. Then m is equal to 3 minus 2 times 1. Then our m is going to be equal to 1 as well. So you have this idea that we have solved it this way. So m is equal to 1 and n is also equal to 1. So this is how we solve this when the two complex numbers are equated to each other. Let's take another one. Given that we have 1 plus 2i all squared, then it is equal to, we have a plus bi, then you have 2 minus I on the other side. Then I think these ones we need to work them out, both of them, because they are not in a standard form. And so for the left hand side, we are going to have 1 plus 2i times 1 plus 2i, which is going to give us 1 times 1 is 1. 1 times this is going to be 2i, then plus 2i, then plus 4i squared. So in simple, you can see that this is going to be negative 4. Then we have 1 minus 4, then plus these ones, these are like terms, then you have 4i, then we have minus 3 plus 4i. So this is a standard form that we're looking for on the left hand side. So on the right hand side, we are going to expand this. We are going to be having 2a, then minus ai, then plus 2bi, then minus bi squared. So simplifying this, you know that this is going to be a real part, because I squared is equal to negative 1. Then you are going to be having 2a plus b. Then this one, we can just remove the common factor, that we are going to be having 2b minus a, and to that. So we can see that even this one is in the standard form that we've been looking for, that this is the real part and this is the imaginary part. So we are going to equate these two things correspondingly. Now what are we having? We have 2a plus b, which is equal to the real part on the other side, which is minus 3, which is equation number 1. Then the imaginary part, we have 2b minus a is equal to 4, which is the imaginary part. They are equal to each other. This is equation number 2. So you can see that you can solve these two equations simultaneously, that you can just have OP being equal to minus 3 minus 2a. Then in the second equation, you can see that you have 2, then our b is that, then minus a is equal to 4. Then you have minus 6 minus 4a minus a is equal to 4. Then you have minus 5a, then is equal to 10. When you take this negative 6 to the other side, then you have 10, then you have a, you have a being equal to just -2. So you have these ones. If a is -2, then you can come back to this one. Then b is equal to -3. -3 minus 2 times that. Then you'll find that you have -3 plus 4, which is just 1. So b is equal to 1 and a is equal to -2. So you can manage to find the unknown values when the two complex numbers are added together. So you can then partake on this one, let's say number 3, that you are to find the values of p and q if we're given that 2 plus 5i into p plus q I is equal to 36 then plus 3i. And this is the first one. Then the second one, you can think of 3 then minus I, then times p plus qi, then you have -2 plus 6i squared, then plus 47, then plus 29i. So if you can just solve these twos, applying the very same idea to find the value of p and the value of q. So this is what this video brought for you. Now we are going to do another stuff when we come back. So enjoy the video. Goodbye.